I'm going to take up homework page 287, number 10. So this is in section 2.4. The question says, if you are dealing from a standard deck of 52 cards, how many different 4-card hands can have at least one card from each suit? So we have 4 cards to choose from. So 1, 2, 3, 4. Sorry, we have 4 cards to choose. And how many are we choosing from? Okay, so from each suit is how many suits are there? There's going to be spades, there's hearts, diamonds, and clubs. So there's 4 suits total. So that means if there's 52 cards in total, and each of them are made of 4 suits, if you do 52 divided by 4, there's going to be 13 of each suit. So that means for this 4-card hand, I have 13 choices here for, let's say, spades. And then I have 13 choices for hearts. And then I have 13 choices for diamonds. And I have 13 choices for clubs. Or if you want to do this, you have 13 spades to choose from, and you choose one of them, times 13 hearts to choose from, and then you choose one of them. Or you have 13 diamonds to choose from, and you choose one of them. And then for the last last card, you have 13 clubs to choose from, and you choose one. Okay, these are the same. And it's going to be 13 to the power of 4, which is going to be 13 to the power of 4, 28,561. Okay, let's do part B. How many different 5-card hands have at least one spade? So we have 5, 1, 2, 3, 4, 5. And there's a couple ways we can do it. We can do it the direct way. So when it says at least one spade, at least one spade, let me write that out. At least one spade, that means 1 spade, 2, 3, 4, and 5 spades. So if we were to do this directly, we need to count the number of ways we can get 1 spade and 4 non-spades, then 2 spades and 3 non-spades, 3 spades, 4 spades, and 5 spades. There's 5 cases. So to me, that's an OMG moment. I'm like, oh, that's a little bit too much for me. So let's take a look to see if there's another easier way, because 5 cases is a lot to do. So let's take a look at the indirect way. Is to get all the different ways. So all 5-card hands, regardless of spades, card hands, all 5-card hands or sets. So we're going to calculate that. And if we take away the number of 5-card hands with 0 spades, 5-card hands or sets with 0 spades, if we take away the ones with 0 spades, we'll be left with the ones with 1 spade, 2 spades, 3 spades, and 4 spades, and 5 spades. So this expression, the result of this expression will be 1, 2, 3, 4, 5 spades, because we're just taking away the one with 0 spades. So it looks like I just have to do 2 calculations here. So the indirect method is actually it's much faster. So how do we get all the 5-card hands? Remember, there are 52 cards in total. So, and it's a 5-card hand. So we're going to do 52 choose 5. And then you take away the ones we have to calculate the 5-card hands with 0 spades. So to calculate the ones with 0 spades, we have, how many cards do we have to choose from? Remember, there's 13 of each suit. That means there's 13 spades. And in this case, we can't choose any spades. So we don't have 52 to choose from. We have to take away the 13. So we have 52 minus 13 cards to choose from. And we're going to calculate what are we choosing from there? Everything else. We're choosing another 5-card hand. So 5 cards that are not spades. So really we have 39 cards to choose from. And those are all the 5 cards, hands, and sets with no spades. So we just calculate that. So 52 choose 5 minus 39 choose 5. And that's going to be 2,023,203. Okay, so let's do part C now. I'm going to have to scroll up because I can't see what's going on anymore. And part C, how many different 5-card hands could have at least 2 face cards? So now we have 5-card hands, 1, 2, 3, 4, 5. We got, face cards, so jacks, queens, and kings. So jacks, queens, and kings. Remember the jacks, there's 4 jacks in the whole deck. There's 4 queens and there's 4 kings. Right? So they want at least 2 face cards here. So over here, I think these could be jack, queen, or king in those sections. And there's really 12, because there's 4, 8, 12 face cards that could go for our 2 there. So again, the question is this very annoying, not annoying, but there's that term right there that says at least. So when it says at least, that means at least 2 face cards means 2, 3, 4, or 5 face cards. So the direct method to directly calculate it, we would need to calculate 2, 3, 4, 5 face cards. Calculate every single 5-card hand with 2 face cards, 5-card hands with 3 face cards, 5-card hands with 4 face cards, and 5-card hands with 5 face cards. So that's 4 different cases that we have to calculate, and that's kind of annoying, maybe. So let's see if there's a better method. Let's take a look at the indirect method. What we need to do is calculate all possibilities, all 5-card hands. And we gotta subtract 0 face cards. And so we need to calculate a hand with 5 cards with 0 face cards, and a hand with 1 face card, a 1 face card hand. So it looks like there's only 3 calculations here. This one has 4, so I'm going to go with the indirect method. So all 5-card hands. So again, there's no restrictions. We're calculating every single possibility. So we have 52 cards to choose from and choosing 5 of them. So to calculate that, that's 52 choose 5. And 0 face cards. So 0 face card hand would be, since there's 12 face cards here, we are going to be choosing from 52 minus 12. So really, we're going to be choosing from 40 cards, and we have to choose 5 of them. So this is all the number of possibilities in which there are no face cards, because we're only choosing from 40 of them. And then here, we want to choose 1 face card. So we have 40. We want to choose 1 face card, so let's go back here. If we're going to choose 1 face card, how many face cards are there? There's 12 face cards. So 12, choose, and we're going to choose 1 of them. And then we still need to get 4 more cards, because it's still a hand of 5 cards. So remember, see how this is, 5 here, that's a 5. There's only 1 here. We only calculated how to get 1 card. We still need to get 4 more cards, and they cannot be face cards because we're only getting 1 face card. We've already settled it here. So again, we cannot choose face cards. We're going to take the 52 minus the 12 face cards, and now we're going to choose 4 of them. And 52 choose. Okay, we just calculate this. So 52 choose 5 minus, what is that, 40 choose 5 minus 12 times 40 choose 4. We get 844,272. 272. Okay, and that answers your question. So if there's any questions, please email me or see me in the chat, and hopefully I can clarify a few things for you. Take care. Good luck. Thanks for watching.